Hello my viewers, welcome once again to my channel Israeli Math Concept. In this video, I'm going to present to you how to deduce the formula for finding the length of an arc of a given circle. And in my subsequent video, I'm going to be uploading videos as regarding to practical questions on length of an arc of a circle. Do well to follow me on Facebook and to subscribe to my YouTube channel Israeli Math Concept so that whenever I drop a new math content, you will be notified. All right, there are some requisite knowledge you should know about a circle that will channel us to this given topic. Remember, a circle is a plane shape of this form. Let me locate the center of the circle using this point. Then the first thing you should know about a circle is the distance round the circle. And the distance around the given circle is what we call the circumference or the perimeter of a circle. Then apart from the circumference or the perimeter of a circle, which is the distance around the circle, there is another important element you should know about a circle, and that element is what we call a chord. And what is a chord? A chord is a particular line that moves from one point of the circumference of a circle to another point of the circumference of a circle. Hence, a line of this very form is called a chord. But there is a unique kind of chord that passes through the center of the circle. A unique kind of chord that passes through the center of the circle. And this unique kind of chord, it is the longest chord in a given circle. And that is the longest chord you can ever have in a given circle. And it is called the diameter of the circle. And remember, the diameter of the circle divides a given circle into two equal parts called the semicircle. Hence, if I pull out this part, I will have something of this nature. If I pull out this part, I will have something of this nature. Hence, these are equal parts of this given circle being splitted by this diameter. Hence, we call it semicircle. We call it semicircle because it is the half of a given circle. All right, there is another important element of a circle called the radius of a circle. And the radius of a circle is a line that passes through the circumference of a circle to the center of the circle. Hence, any line that passes through the circumference of a circle to the center of the circle is called the radius of a circle. It doesn't matter the location. I could still draw it from this point of the circle to this point. It's still the radius of a circle. Once it passes through the circumference of a circle and to the center of a circle, we call it the radius of a circle. And remember, the radius of every circle is equal. So automatically, this, if I call this radius 1 and call this radius 2, both the radius 1 and radius 2 are equal. Once you're able to draw your circle using your pair of compass, the radius of a given circle at any point it is being located is equal to the other radius of a given circle. Then there is another element you should know about a circle. Let me assume this point to be A, and I assume this point to be B. Then from point A, the distance from point A to point B, we call it an arc of a circle. So the distance from the point A to point B is called the arc of a circle. And this arc is small compared to the arc from point A here running through up to point B here. So automatically, this smaller arc from point A to point B is called the minor arc. The minor arc. The minor arc. Why the arc from this point A that passes through this point up to point B is called the major arc. The major arc of a circle. Having understood the concept of minor arc and major arc, there is another important aspect of a circle I really want to introduce to you. And that important aspect of a circle is what we call segment of a circle. If I have a chord of a circle of this form, This very chord divides this very circle into an unequal part. So the major part of this circle is what we call major segment of the circle. Major segment. While the smaller part of this very given circle that is being splitted by this given chord is called the minor segment. Then the last element of a circle I would love to introduce to you is what we call the sector of a circle. Let me locate this given circle, the center with a point of this form. Then this is my radius, the first radius, and this is my second radius. Let me assume this center of the circle to be O. And from this very point to this point, which is the arc of the circle, let me take it as AB. So I have arc AB. See, if I pull out the 3 points, which are A, B, and O, I will have something of this form. Hence, this is what we call the sector of a circle. And every sector of a circle subtends an angle at the center of a circle. All right, having gotten the concept of a circle and some properties of a circle, I would now like to go in details on how to deduce the formula for finding the length of an arc of a circle. All right, let's consider these two given diagrams that are well drawn on this board. Remember, I told you prior that the point PRQ is called the minor arc. Then, looking at this very second part of the diagram, the point PSQ, which is the point from this very point to this very point, we call it the major arc. So automatically, the distance from point P up to point Q is called the minor arc, and also the distance from point P through S up to point Q is called the major arc. Hence, every given arc together with this given radius subtends a given angle at the center of a circle. Then, how do we deduce the formula for finding the length of an arc of a circle? It is very easy. Remember, this is the minor arc, while this is the major arc. So the formula for finding this given arc of this given circle is very simple. Hence, we say that the length of arc of a circle is equal to the theta. Remember, the theta is the angle that this arc subtends at the center. Assuming I call this center of the circle O, so automatically this is the angle that this given arc subtends at the center of the circle. So the angle is represented with theta. So theta is the angle that this given arc of a circle subtends at the center of this circle O. Then the length of an arc of a circle is this angle that the arc subtends at the center of the circle out of the total angle that we are supposed to have at the circle, which is angle 360, angle on a point, times the perimeter of the given circle. It is very simple. I want to repeat that the length of an arc of a circle, that is the length PRQ, or the length of the arc PSQ, is equal to the angle that this arc subtends out of the total angle, which is angle of a point on a circle, multiplied by 2 pi r, and the 2 pi r is the circumference of the circle, which is the distance around the circle, or you call it the perimeter. Hence, the length of an arc of a circle PRQ or PSQ is equal to theta over 360 times 2 pi r. Thank you for viewing. Thank you for watching. Remember to subscribe to my YouTube channel, Israeli Math Concept, and to follow me on Facebook for subsequent videos I will be uploading as regarding to a practical questions or problem on length of an arc of a circle. Thank you and see you next time. Remember to share this video. Goodbye.